Hey everybody, Steve here again. We have a nice probability problem involving dice. So first, before we go to answer these specific questions, let's do a quick review of what is probability. So here I have an equation. Probability of an event, E, is going to be equal to the number of events that are successful, so the successful outcomes that's in the numerator, divided by the sample space, which is the denominator. And so what we have for the red and black die here is clearly with a die, a six-sided die. The red die has options 1 through 6, and similarly the black die have options 1 through 6. So if I look here, my table basically shows, okay, if I roll a red 4 and then a black 2, that's the outcome here. So here are all of the various outcomes. So notice it's 6 times 6. I don't have to count these. I can just multiply these two together. 6 times 6 is 36. So that is going to be referred to as our sample space, and that's going to be the denominator that we're going to use to find all of the probabilities in the next problems. So for part B, it says, what is the probability that you roll a red 5 and a black 6? So I'm going to go to my pencil here, and here is my red 5. Here is my black 6. Notice I only have one choice right here that is possible, so I only have one choice. So the number of successful outcomes right here would just be 1. Now notice here I'm not calculating the probability, but I'm giving you basically the numerator and the denominator. So for part B, the answer is not 1, but instead it would be 1 over 36. So for the next question, C, it says, what is the probability that the sum of the two dice is at least 4? So notice the table that I have below here, this is now the sum of the dice rolled. So here again is our red and our black. But now if we roll a 1 red, 1 black, 1 plus 1 is 2, or 2 plus 1 is 3. So these are basically the sum if I add the two die together. So that's what this table is showing. So again, it's saying the probability that the sum is at least 4. Okay, so basically here's 4, here's 5, it goes all the way to 12. So what I could do is I could literally go in and count like all of those, or there's kind of a trick here. Well, if I say, well, 3 is not 4 and 2 is not 4, and the problem is saying at least 4, so 4, 5, 6, 7, all the way to 12. So here what I could do is say, well, 2 and these 2 3s here, there are 3 negative outcomes. So I know there's 36 total outcomes, 3 negative outcomes. So what I could do here is simply subtract 36 minus the 3 negative outcomes to get 33 positive outcomes. So here, the numerator would be 33 divided by the total sample space of 36. So 33 over 36. And a hint, you can divide both by 3 and reduce it to 11/12. Okay, so that is an alternative way to do part C, is by looking at the negative outcomes as well. Okay, part D here, what this is saying is the probability that the sum of the two dice is at most 4, at most 5. So it could be 2, 3, 4, or 5. So again, what we could do is essentially go through these and count all of these outcomes. Okay. And if we do, we can go and see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is the successful outcomes where it is at most 5, okay? And so remember, this is just the numerator, so the final result would be 10 over 36. And again, a hint, you can reduce that if you divide both by 2. Finally, what is the probability that the sum is 14? So the word is means equal. So it's exactly 14. So we go to our table here and there is no 14. So the highest, right? If I roll a 6 and a 6, it's 12. The sum that we're going to get 14 is 0. It's not going to happen. Okay, so the event outcome here is 0. The numerator would be 0. 0 over 36 is 0. So I hope this sheds some light. Drawing these tables, looking at this space is quite helpful for you, and we look to see you next time.